You know, when it comes to your money, a little bit of paranoia is actually a very, very good thing. So today, we're going to dive into why the very best programmers are, well, a little paranoid, especially when they're building the systems that are meant to protect our finances. Just think about that for a second. Imagine a system that just assumes everything's fine, that the application sending it commands will never have a bug, never make a single mistake. Yeah, that sounds like a total recipe for disaster, right? Well, that's exactly why we need to build these systems differently from the ground up.
And this right here, this is the core idea we're unpacking. Real banking databases are built to be paranoid. They simply do not trust the application code. Now, this isn't about blaming developers for making mistakes. It's about building a fortress. The database itself, the place where the money is actually tracked, has to be the final unbreakable line of defense, and it has to be suspicious of every single request it gets.
So, okay, how do you actually build this thing? You build what we're calling a paranoid database. And in this world, trust is a liability. The entire system is designed from the very beginning to assume that something, somewhere, is eventually going to go wrong. It prepares for the worst-case scenario, all to keep our money safe. And this is absolutely crucial. The rules don't just live in the application code, you know, the part you see on a web page or in your mobile app. No. They are baked directly into the very structure of the database. What this means is, even if some buggy application tries to do something completely impossible, like create a negative money transfer, the database itself, our fortress, is just going to slam the door shut.
So let's take a look at the actual blueprint for this digital vault and see how it's all put together. We're going to look at the specific rules or constraints that are built into the database tables for members, accounts, and transactions. This right here is the architecture of our paranoia.
All right, let's start with protecting customer info in what's called the members table. First up, every single email has to be unique. That one simple rule prevents a bug from accidentally creating two accounts for the same person. We also have a check for a valid user status, and even a really basic check that an email looks like an email. You know, it has to have an @ symbol in it. It sounds simple, but it's incredibly effective.
Okay, now for the money itself. The accounts table has one of the most important rules in the whole system. See that one? Foreign key with on-delete restrict? I know, it sounds super technical, but what it means is actually brilliant. You simply cannot delete a member if they still have an active account. This rule, all by itself, prevents a bug from making money just vanish. It creates an unbreakable link between a person and their money.
And finally, you have to have a clean audit trail, a perfect paper trail. Every financial event is a transaction, and the transactions table has a golden rule. The amount has to be positive. Think about it. You can't deposit negative $100. A withdrawal is just a withdrawal type transaction of a positive $100. This simple check prevents all kinds of impossible accounting and keeps the records perfectly accurate.
So we've built our vault. It seems strong, but how do we know for sure? Well, we try to break it. This is something called negative testing. And here's the fun part. The goal isn't for our tests to succeed. The goal is for them to fail in exactly the way we expect them to. A failed test is actually proof that our defenses are working. All right, first up, we're going to try to create a new user. But here's the catch. We're going to use an email address that we know is already in the system. Let's just say alice@test.com. And boom, here's what happens. The attack on the left tries to insert that new member, but the defense on the right is the database firing right back with an error. Violation of unique key constraint. It's basically yelling, nope, you can't do that. I already have someone with that email. The test was a success because it failed. Okay, on to the next test. What if some buggy code tries to create a user with just a garbage email address? You know, something that's clearly not valid, like bob_@gmail.com. And once again, the database just flat out rejects it. Our simple little rule that the email has to have an @ symbol kicks in and does its job. That error message, check constraint, check_email_format failed, is exactly what we want to see. Our paranoid check worked perfectly. All right, now for the big one. This is probably the most critical stress test of all. We're going to try and delete a member who we know, for a fact, still has an account with a balance in it. This is the absolute nightmare scenario. And just look at that beautiful error message. Foreign key constraint fails. The database is literally refusing to orphan the money in that account. That on-delete restrict rule we talked about, it just saved the day.
This isn't just a failed test. This is a massive, massive success for the integrity of our entire system. Okay, one last test for the road. Let's try to break the laws of financial physics and create a transaction for a negative amount of money. Let's say negative $500.
And just like we hoped, the database says, nope, not happening. The check_amount positive constraint catches this logically impossible request and shuts it down. Our paper trail stays clean, it stays logical, and it stays trustworthy. Another successful failure.
So after all that, what did we just prove? We proved that in a paranoid system, failure is the ultimate sign of success. Every single time our attack was blocked, it was a huge victory for our design.
So let's just recap how we proved our vault is secure. Our defenses blocked duplicate users. They rejected invalid data. They prevented money from being orphaned. And they stopped impossible transactions from ever happening. Every single one of those failed tests just confirmed that our database rules are the critical safety net we need them to be. When you get right down to it, all of these technical constraints, these checks, and these rules, they aren't just for programmers. They are the digital foundation of trust. We can trust our bank because we know its systems are built on this kind of paranoid, defensive design.
And that really leaves us with one final thought to chew on. If a safety net has never, ever failed, how do you really know it's even there? Sometimes, the most reassuring sound in the world of software is the sound of a well-designed system simply saying no.